One of the skills you need to be able to do is, given information about an image, you need to be able to calculate its file size. Okay, so to do this, the two key bits of information you need are the resolution of the image. So in our example here, we've got 7 by 7, and the color depth, which in our example here, we've got 1 bit. So we've got 1 bit per pixel, our color depth. We've got 7 pixels wide by 7 pixels down, which is our resolution. So once we've got that, we go through the steps. Okay, so the first step is to work out how many pixels we've got. So we know 7 by 7 is 49. So there's 49 pixels within our image. Step 2 is, once we know how many pixels we've got, we times them by our color depth, so we know how many bits we're using. In our example, we've only got 1 bit per pixel, so therefore 49 times 1 is 49 bits. So in our entire image, we're using 49 bits of data. Now, step 3, this is where you would work out how many bytes of data that is. Because it's 49 is over 8 bits, we're therefore going to need to store it in bytes. So you try and use the smallest unit of measurement you can, or the biggest unit relative, you know what I mean. So what we've got there is we've got 49 bits, so we'll divide a bit by 8 to get its next measurement, which is bytes, which equals 6.125. Now, if you ever do a division when you're calculating file sizes, never round down. It's a common mistake people make, but if, say, I don't know, you've got 3 drawers in your chest of drawers at home, and you've got a certain amount of data that's going to fit in 2.5 drawers. You can't round down and only use 2 drawers, because what's going to happen to that stuff that you couldn't put in the half of it? If you fill 2 drawers, you've got half left. So you always round up. If you've got too much data for too much stuff for 2 drawers, you've got to use 3 drawers. Okay, so always round up. So in our example here, although we had 6.125, we'd have to round up to 7 bytes because we don't want to lose any data. And essentially, step 4, we just continue to, once we've got the amount of bytes, if that amount of bytes, which it typically would be over 1,000, we just keep dividing by 1,000, increasing the unit of measurement. So if it was firstly divide by 1,000, get kilobytes. If our answer is still over 1,000 kilobytes, then we divide by 1,000 and measure it in megabytes. If we then go over 1,000 megabytes, we divide by 1,000 and go with gigabytes, etc., etc. So let's just do one really quick proper example. So a desktop wallpaper image for a computer might typically be a resolution like this. So 1024 by 768. It might have a 24-bit color depth. This is a more realistic image. So the first thing you do is work out the amount of pixels. So you times the resolution by each other to work out the pixels. Then step 2, if we've got 24 bits of data per pixel, we times the amount of pixels by 24 bits to get our crazy long amount of bits in the entire image. Then we divide this by 8 to work out the amount of bytes. So it equals that 2,359,296 bytes. Clearly that amount of bytes is still over 1,000, so we need to go through the next steps. So the next step would be divide by 1,000 to turn it into kilobytes, because kilobytes is a measurement of 1,000 bytes. So that long number divided by 1,000 equals 2,360 kilobytes. As that number is still over 1,000, we go again. So divide by 1,000, that's meant to be megabytes. Divide by 1,000 for, ignore that. After kilobytes, it goes to megabytes. So divide by 1,000 for megabytes. That should be 2.4 megabytes. And that would be the answer. Please ignore those two tiny bits.